Okay, so today we are looking at complex solutions for polynomials. So when we were doing our algebra part of it, sometimes we ended up with our factorising coming out with a quadratic from a cubic and one linear factor, so x plus 2, x squared plus 5x plus 7, or something like that. So one was the factor and the other one didn't give you factors. But the problem is that that particular one that didn't give you factors is likely to have complex solutions. We looked at how to solve those quadratics using the quadratic formula, getting our 3 plus something or other I, right? So we can get the complex solutions, but we're going to look at a couple of other ways at the moment. So let's just have a look at one, a very basic one to start off with. What if we had x squared equals negative 16? All right, so negative 16 means that when we take the square root, we've got plus and minus the square root of negative 16. So in Year 12, we would have written it has no real roots. And it doesn't have any real roots because it has two complex roots. And what are those complex roots? They are plus 4i and minus 4i. All right, so we've taken that square root of 16 and turned it into 4i. So this sort of tells us that we can have two complex roots. So this indicates no real roots, but we can have two complex roots. Now, complex roots, imaginary roots, they're a little bit more interesting than the real roots because there is something called the conjugate root theorem. So we know what a conjugate is. It's when we change the sign on the imaginary part. And there exists a theorem that says if you have the positive root, the one that goes 3 plus 2i, being a factor, then, or a root, then the negative one will also be a root, all right? So in simple terms, if w is a root, remember w is a complex number, then w bar is a root also. E.g., we've got 3 plus I is a root. We don't have to do any work to find out that 3 minus I is also a root. Right, so conjugate, change the sign on the imaginary part. All right, so if we, let's have a look at if we know that 3 plus I is a root and 3 minus I is a root, where does that come from? What quadratic does that come from? So this is kind of working backwards. So if those were the roots, then they came from x minus 3 plus I and x plus 3 plus 3, x, don't do that, plus equals 0. That's where it came from. Those were the solutions, all right? So if it came from those solutions, all right, those should be minuses because they're not negatives, they're positives. We had that right in the first place. Okay, so that would mean we'd go from there to these two statements. So if we're going backwards, we need to multiply this out. So we're going to get x squared minus x times 3 plus I minus x times 3 minus I plus negative times negative 3 plus I times 3 minus I. Wow, that's really complicated, but what we're trying to find is the quadratic that produced these roots. So this part here gives us x squared minus 3x plus ix, not plus, minus x times minus 3x plus ix plus 3 times 3 is 9 plus 3 times negative I is minus 3i plus 3i. I times I is square root of negative 1 squared, negative 1, 1's negative, plus I equals 0. Oh, not plus I. Alright, so we're doing I times the negative I, which is square root of negative 1 times negative the square root of negative 1, which equals negative the negative 1, which means plus 1. Okay, so now we can tidy this one up. So that cancels with that cancels with that, and we should end up with no i's left because we don't have an I in a quadratic equation, and we need to just group the rest together. X squared minus 6x plus 9 plus 1 is 10 equals 0. So if we did b squared minus 4ac, b squared minus 4ac, that would be negative 6 squared is 36 minus 4 times 1 times 10 equals negative 4. So we would normally have written no real roots. We didn't have real roots, we had complex roots. All right? So if we were going to go the other way round, solve x squared minus 3x plus 5 equals 0. Easiest way to do this is to find out what b squared minus 4ac is first. So we go b squared minus 4ac equals 9 minus 20 equals negative 11. Alright, so what do we get? We get x equals negative b, so 3 plus or minus the square root of negative 11, b squared minus 4ac, over 2a, which is 2. So there are our two complex solutions. We've got 3 plus, what does that equal? Yep, square root of 11i over 2, and 3 minus the square root of 11i over 2. Two complex solutions, perfectly written. All right.